Hello, this is Miss Dagenford, and I wanted to share with you today the differences that you see in respiratory systems and circulatory systems in our vertebrate classes. Now, the other class, we were looking at the different classes and what kind of made them distinct. And so we saw the agnatha, the jawless fishes, or the jawless vertebrates. And then we saw the two different types of fish, the cartilage fish versus the bony fish. They were noted to have jaws, and once you have jaws, you become better predators. Then we have in amphibia, aves, and mammalia. Those would be the amphibians, birds, and mammals. They are known for being tetrapods. They have four limbs. And then we have reptiles and birds and mammals, which are amniotic. And then we have mammals, which have fur, and birds that have feathers. So that's just what else should we know about vertebrates before we compare them? And one of the things that's going to help you when as we compare them would be to look at whether or not they're ectothermic or endothermic. And ectothermic are what we used to call cold-blooded. Now, you still hear that term, but it doesn't mean they're always cold. It simply means that they can't regulate their body temperature, or they don't. They don't have the system in place. So they rely on behavioral habits, so warming in the sun or cooling in the shade. Now, this limits where they can live and when they are active, and it also then limits their activity. And so this kind of brings us to the circulation and the respiration. Because if you are not very active, then you're not requiring as much oxygen. Now, conversely, if you don't have the mechanisms to be active or to provide that oxygen, then you're not going to be able to be that active. So, if you cannot regulate your body temperature, if you don't have the system in place to bring the oxygen there, then that's going to, you're going to see that in the muscles as well. Larger muscles and more activity require higher metabolic activity. So, reptiles and amphibians don't achieve that same breadth of activity. They can have bursts of speed or bursts of activity, but they generally don't run on four legs on top. They don't support their body. They don't run on two legs. So that's going to affect them. Endothermy is where you can maintain your body temperature. Birds, mammals, and a few others. There's a couple of fish that can warm themselves up with their muscles. There's a couple of insects that can affect their body temperature. But by and large, we're seeing birds and mammals. And what they do is they regulate through a homeostasis negative feedback mechanism. So if you get too cold, your whole point in that system is to warm you up. If you get too hot, you're going to have mechanisms to which cool you down. Now, for humans, if we get too cold, we shiver and we constrict our blood vessels. Now, all mammals and birds can do that, but other mammals and birds have feathers and fur to also regulate and protect them from being too cold. Fat layers as well can help you insulate. If you get too hot, we sweat, dogs pant, elephants can dilate their blood vessels in their ears, letting the heat radiate from them. And so all of these things can help maintain that 98 point and give or take. It's going to always hover around that 97, 98. Some animals go above 100, but 102, 103. But it's always going to be somewhere around there. Now, what this is going to allow them to do is maintain that body temperature so they don't have to worry about whether or not they're too cold in the morning, like reptiles do, or whether or not they're too warm. Now, they're still going to find and regulate their activity during the day, but we're not limited as the ectotherms are, and that's going to be really important. The other thing you're going to notice here is that we're going to see the most complex respiratory systems and the most complex circulatory systems. And that is going to provide more oxygen, more efficiency, more oxygen, more oxygen delivered to muscles, bigger muscles, more muscles, and more muscles or bigger muscles mean that you can support more activity. You can get up on two legs, think ostriches, right? And you can see that in humans, right? More muscles, more active, more hunting. And that even affects the brains. If you can provide better oxygen to your brain, that's going to support that thinking and processing that allows them to be better hunters and be better foragers. So you will notice that the birds and the mammals will always have the most need and the most complex systems. And there are a couple of little videos that you guys can watch that will help you kind of understand this. So let's take a look let's take a look at the respiratory system. Now, a lot of this you already have learned, and so you guys can take a quick pause and ask in your class, what are the things that you know about the respiratory systems? What's the purpose? What do they do? So if you did that, you probably nailed down the fact that respiratory system helps get oxygen. And then get rid of carbon dioxide. And that is its sole job. That is what we want to do. And how do we do it? Well, all respiratory systems basically have a simple operating mechanism. They bring capillaries close to the respiratory membrane, and that's where it's going to interface with either water or air. And because it's getting the capillaries really close, it's going to allow for the diffusion of oxygen and carbon dioxide. Oxygen is going to diffuse in, and carbon dioxide is going to diffuse out. Now, that means you need to have a high to low concentration, good old diffusion. And so, for instance, in gills, notice you've got a fish bringing in water from their mouth, and it's going to pass over their gills. And gills, notice the surface area, lots and lots and lots of these filaments, very feathery, very filamentous, and each filament is going to then have capillaries that are going to run across the lamellae, these parts of the gills. And so the whole purpose is to let water drift over the lamellae, and then the capillaries are there to pick up oxygen. Now, they do something really interesting that they have a counter current exchange, and that means that the water is going to go in a opposite direction than their blood flow. Now, there's a really cool design about this. If you notice the numbers here, the numbers represent the amount of oxygen. And so as the water first encounters the blood, the capillaries, it's 100% partial pressure of oxygen. And notice the capillaries are 80%. That's still higher. 100 is still higher than 80. Oxygen's going to diffuse. Now, that means oxygen gave up a little bit of water gave a little bit of oxygen up, so now it's at 70. But notice the direction of the blood flow is coming from oxygen poor. So it hasn't picked up oxygen yet, so it's at 60. It's still 70 is still higher than 60. It's oxygen's going to diffuse. Water loses a little bit more of its oxygen. It's down to 40, but the blood is still coming from oxygen poor areas and it's only at 30. So it's going to diffuse. And then one last time, we're down to 15 in water, but oxygen poor venous blood is coming at 5. So by having opposite flow, it never allows the blood to equilibrate and you get more oxygen that way. So we have gills, and the frilliness increases the surface area, and that countercurrent mechanism where it's opposite ensures that the oxygen concentration is always higher in the water and lower in the blood, and so blood is going to absorb oxygen. Pretty clever. Now, the other thing that you can realize about fish, they notice they can have more than the four, they're not tetrapods, right? They have more than four fins. And so we're not at the tetrapods yet. We're still at fish. So we have paired fins, and then we have the lateral fins, dorsal fins, tail fins, and that is going to be quite distinctive for them. Now, the other thing to keep in mind with the terrestrial had to do with the ectotherm versus endotherm. So notice in both of these pictures, the lungs are going to be folded more and more, and you can see that between the salamander and frog and the lizard, the lungs are going to have smaller and smaller air spaces. And that's going to increase surface area. And especially when you get to the birds and the mammals, that surface area is amazingly high. And that means you're going to be able to absorb more oxygen. And the structure that you guys might recall from your middle school days would be alveoli. And the alveoli are the little spherical air sacs that are at the ends of the respiratory tracts. Now, the alveoli, the whole purpose of the alveoli is to be very, very thin, and that's going to allow oxygen to diffuse in and be picked up by blood cells, and carbon dioxide to be to diffuse out into the air in the air sacs. There does have to be fluid lining this, but it's just a very thin fluid. It's going to be that's what's going to allow the oxygen and carbon dioxide to diffuse very well. So these are very, very thin, one cell thin capillaries are going to encircle, and you get this huge network. You can see the alveoli. Each alveoli would be covered in capillaries. And you can see the little GIF over here. The oxygen is being absorbed, carbon dioxide is diffusing out. So we're going to go over the parts of the respiratory system, but see if you can identify some of them before I do that. So hit pause and see what you got. Okay, so we're going to start from the top down. So the top down, you should have noticed nasal cavity. Now my arrow is a little low. I'm going to scoot that up a little bit. So there's our nasal cavity. I don't think that's a outrageous thing. You have the mouth and then the pharynx, which is the back of the throat. And then we have our voice box below that, our larynx. And above the larynx is the epiglottis, which I didn't label, but you probably remember where the epiglottis prevents food from going down. Then we have the trachea. And then when the trachea splits, you have the bronchus. And then I need one more box, and that would be our lungs. So let me go ahead and just add that there. And so there is your quick, that is your quick summary of the respiratory system.